Hi everyone, welcome to this webinar about Introduction to Backend. In this webinar, we are going to talk about backend technologies, what backend actually means, what are the various cogs and wheels that make up a backend for a web server, right? This is third in series of webinars that actually fourth in series of webinars that we are conducting. The first one was Introduction to Web Development in general, and then we have had two webinars about front-end technologies. With this one, we take things to the backend, that is the web server, where we will write secure code in secure environment, which will allow us to present a better experience to our customers. Right? Without any further ado, let's jump into our presentation here. So for today, these are the topics that we would be covering. First of all, before we start backend development, we need to know what backend is, what it comprises, and what functionalities can we use it for, right? Followed by that, we'll take a brief look at in what cases you should consider creating a backend server, right? Followed by that, obviously, what programming, since it's related to programming, what programming languages could be potentially used, right? Then we have HTTP. This is, as we talked about in the first webinar, HTTP is the language used for communication between multiple computers on internet, right? So we'll see some details about HTTP, what kind of functionalities HTTP supports, and what you can build using HTTP as a language, right? Followed by that, we will look at something called APIs and REST APIs. Both of them are specific patterns for using HTTP. And then we have HTTPS, which is something that you should already be familiar with. These days, any website that you visit, instead of saying HTTP:// it would say HTTPS://. We'll see what HTTPS is all about. And followed by that, we'll talk about cloud technologies a bit and how they have changed the web development landscape in general. Okay. I'm expecting all this to take around 40-45 minutes, and we'll spend about 10 to 15 minutes on Q&A. And yeah, we'll take it from there. Okay. So the first thing, what is a backend? I should actually say, what is a backend server? Backend server is a web server or a computer which is connected to internet and is running a program to provide some utility for the user, right? So your backend server could be a computer and the program running on that computer, which allows user to chat with each other, or it could be a program running on a server which allows users to do a video chat or view videos the way you are doing right now on YouTube. YouTube runs tons of backend servers just to be able to stream videos from some computers in world. It could be in US, it could be in India, to your device, wherever you are located, right? Along with being connected to internet, backend server must have few other attributes. And these attributes are not defining features of backend server at all. These attributes are something that are necessary on a backend server. Um, a backend server could be built without these features too, but in that case, it won't be as useful. It won't have the intended effect on the functionality. One of those attributes should be the backend server should be safe. Not everyone should be able to see what is going on your server. It should run your code alone. No one else should be able to put their code on server and then compromise the integrity of your system, or be able to steal data of your customers that you have stored. For example, if you are chatting with someone on any of the chat platforms, right? Let's take Telegram for example. No one should be able to put their code on Telegram servers and see your chats. That would simply not be acceptable, right? It should be secure. It should not it should not provide physical access to other bad actors, or it should not provide internet access to bad actors either. Not everyone on internet is a good person, right? Some people might simply be trying to steal data. Some people might simply be trying to break down the system. And your backend server must be secure from all such actors. It must be able to withstand the test of time and load, right? And additionally, it must always be connected. That's a given, right? If you put some program on your backend server and your users rely on that program, your users regular life, the businesses will rely on that program. In that case, your server should never go down. It should never lose internet connection. It should always be connected to internet, right? Moving on, we see what a backend server is used for. We just talked about what a backend server, like what we could potentially call as a backend server, right? Let's also talk about what a backend server is used for. In what scenarios should you consider building a backend server, right? Now, one of the major use cases, or one of the major concerns which should prompt you to build a backend server is the consideration of whether your code should be run in secure environment. Do you want your customers, do you want anyone on internet to be able to see your code or not? Any code that you write to be run in browser can be seen by anyone. If your code is proprietary, for example, your business depends on that code, or that code provides a unique advantage to your business, right? Then you should not put that code in browser, because then anyone will be able to see, anyone will be able to replicate that code. To keep your code proprietary and safe from bad actors, you will need to put that code and run that code in a secure environment, which is our backend server, right? Second thing to consider would be, what actions should you consider secure? Any action that you consider secure should not be done in browser. Instead, it should be done in a secure environment on your server. Now, I'd give you some examples of these secure actions, right? Think of password validation, for example. You cannot validate users' password in the browser, because in that case, you are opening yourself up for a huge amount of cheating. If you think about it, right, if the password is only stored in browser and it's only validated in user's browser, what prevents me from not modifying my browser and telling that, yeah, my password is correct all the time? Like, I try to log in with your username and simply say, yeah, no, whatever password I wrote is simply correct, and server will have to trust me, or you will have to trust me, because you have no control over browser. Browser is a program that was written by someone else. It's running on someone else's computer, and even the code that is running in browser, you cannot be sure that it's all your code. Any other website could be loaded in the browser too, right? So any action that you'd consider secure should be done on server side, and you'd want to create a backend server for that, right? Another thing that you'd want to create backend server for is heavy lifting, which I mentioned as computationally intensive tasks, right? What computationally intensive tasks mean is, take an example, right? Let's imagine you wanted to find the 1 millionth prime number, right? Now, there are computers in the world that could create 1 millionth prime, that could find the 1 millionth prime number in matter of seconds, right? And there are also computers in the world which would take hours to find the 1 million prime number. I'm not getting into specifics of why you'd want to find 1 million prime number. That's just an example. It could be any other computationally intensive task, right? I'll give you more examples after this. But continuing forward with our 1 million prime number example, right? Running that program on a mobile device will take hours to run, right? Running it on a relatively powerful desktop will also take few minutes to tens of minutes to run. Running it on a really powerful GPU will take few seconds, right? Now, you not want your customer to have such varied experiences. For example, if you go to any reputed website, for example, your email provider, if you go to your email provider site in your desktop and it loads in seconds, but if you go to the same site in your browser, it takes minutes to load. You'd not want that experience. That's really, really bad experience for your customer, right? So in these scenarios, whenever you need to do computationally intensive tasks, you'd want to create a uniform environment. You'd want to run it on server side so that same experience is available to all your customers regardless of what device they are using, right? And you can be sure that there will be a variety of devices being used to access your website. You'd have very low-end Android phones, you'd have very high-end Android phones, or most of your customers will use something in between, right? And same goes for desktops also. You could have netbooks which have few GBs of RAM and almost no hard disk, so no caching. Or you could have a really high-end desktop which has 32 or 64 GB of RAM, and that's able to do computationally intensive tasks fairly well, right? So to provide uniform experiences, you should have all the computationally intensive tasks moved to a backend server where it can be done in relatively fast time. Sometimes it will take time even on backend server, but at least it will be uniform. Everyone, regardless of their device, will have same kind of experience, right? So I took million prime number as example, right? You could take other examples also. For example, data mining, or mining bitcoins, or running a machine learning algorithm. All these things are supposed to take lots of CPUs, and most of devices on which your website will be accessed, it's simply not equipped to do that. And for all that, backend, right? And the last point, data storage. This actually ties into everything else that we have talked about too. And I put it in the end for to be able to highlight it even more, right? That you need your data on server side to be able to do everything else that you want to do. Now, the most common reason why you cannot put data on client side is security. Anything that you put in browser can be and will be accessed by anyone else having access to that browser. For example, any data that is stored in my browser could potentially be accessed by anyone else in my family or any of my friends who just come and ask to borrow my laptop for some time, right? So it's simply not secure. I'd not want my credit card numbers to be insecurely stored in my browser. I want it to be stored securely in some server which is protected by multiple layers of firewall, or which is protected by physical security too, right? Second reason for not storing data in browser would be you have no control. As a web developer, you have no control over user's browser. Once the user navigates away from your website, right? Let's say a user came to your website, www.example.com, and you stored some data on their browser. Once they navigate away from your website, from example.com, they go to example2.com or google.com or any other website that they want to visit, right? You have no control over that data. You cannot fetch that data. You cannot run any kind of analytics on that data to figure out what happened or how that data was used, right? So data is insecure, data is inaccessible in browser, and if your browser or if your computer crashes, right, then the data is lost also. It's not permanently stored. To get rid of all these problems, most of the websites would typically prefer to store data on server side where they can control it, they can secure it, and they can access it anytime necessary. Okay. By the way, if you guys need me to go slow, or you have some questions, right, feel free to stop me. Just post a comment on YouTube. I'll be able to see that. I'll stop and I'll answer that before we move forward. Okay. All right. So for now, I'll move on to how to create a backend server. I briefly touched upon this in our previous examples too, in our previous webinars too. So to create a backend server, you don't need to do much. It's like creating any other program that you have written. If you have some experience with programming, you'd have already created a program that can take input from a user, that can process that input, create some kind of useful information, and then be able to respond with that information, then output that information somehow, right? So input, process, output, it's the normal cycle that any program takes. It's the same for backend program also. It's the same for any web server also. Needs to take input, process it, and provide output. The only difference is the input and output legs of this journey have to happen somewhere else. Your web server should be capable of taking input from a remote computer. For example, when you try to search something in Google, right? Google servers are capable of taking input from your browser, processing it, finding out what search results are relevant to your search term, right? And then providing the output back to your browser. So the basics remain same, but the specifics do differ. The input was taken from your browser, processed on some other computer, and then given as output to your browser, right? So the only way backend server program differs from a normal program is that it's capable of taking remote input and providing output to a remote computer, right? And as for the programming language, in which programming language can we do all this, right? As far as that goes, the answer is pretty much any programming language. Even though I've highlighted just a few over here, like Java, Python, PHP, Node.js, these are the most common programming languages that we use today for creating a backend server. But this is by no means an exhaustive list. There are so many other programming languages that you could potentially use for creating a backend server, as long as you are able to add that extra layer on top of it, so that it's able to take input from a browser and provide output to the browser in most probably a format that browser can understand, right? As we have seen in our previous webinars, such an format would be HTML or a video or a audio, like any format that browser can understand. As long as output can be provided in such a format, you can create a backend server. These languages are more of an indication of what people use than of an indication of what potentially could be used, right? These are languages that are typically used by web developers, right? Here's the kicker then. How do you choose a programming language? If there are so many programming languages and you can use any language potentially for creating your backend server, how do you go about choosing a particular language that you should create a create a backend server in? Think about it. You think of a very cool business idea and you want to implement it yourself, right? Or even if you want to hire someone else to implement it. In that case, the first question the developer will need to answer is that what programming language should I create the backend server for this website in? And the answer almost always is choose the programming language you already know. If you already know a programming language, you should almost always go with that. For the very, very simple reason that you want to create a very safe and secure program. You do not want your program uh, to be misused on internet, right? Since your program will be available to anyone on internet and there are all kinds of people on internet. You'd want it to be as safe and secure as possible and as accurate as possible. In that case, simply choosing the language you know kind of puts you at an advantage. You don't need to learn a lot about how to make your program safe, how to keep your program hidden from bad actors, and so on and so forth. So yeah, that's that. But if you are starting as a new developer, right? If your aim is not to set up a business, instead your aim is to learn a new programming language, right? In that case, this is how you go ahead about selecting a programming language. Java, which is very, very popular on internet, is a general purpose programming language, and it's very good for heavy lifting. It's very good for doing multiple things at once, multi-threading, what we call in programming terminology, right? Java is very good at multi-threading. It can do relatively intensive tasks, relatively computational tasks very well. So yeah, if you do not have much idea about what kind of processing power you'll need, and you want to go with something very generic, which can handle easy things as well as really, really tough computational needs, right? Then you could go for Java. Python again is a general purpose programming language. It can do pretty much everything that Java can do with pretty much the same speed that Java can handle, slightly slower. But yeah, Python could also be used in place of generic requirements, right? But Python is specifically very, very popular among machine learning and artificial intelligence enthusiasts. So if your use case involves, at least in some part, machine learning and AI, you should most probably choose Python, simply because a lot of people that will be working on your backend server, that will contribute in code to your backend server, might already be popular with Python. This kind of ties back into our choose the language you know directive, right? If most of the contributors on your project are going to be familiar with Python because they are using ML and they're using Python for ML and AI, in that case, it makes sense to go with Python for the rest of the needs also, right? The third language on list is C++, and I only added this for sake of completeness. C++ is a programming language that's not typically associated with internet, right? Even though C++ powers a lot of programs running on internet, Nginx, Apache, these are very, very popular web servers, and both of them are written in C++. Curl is a very popular HTTP library, again written in C++. So C++ makes up the bedrock which builds the internet on top of it. But as a backend language, right, as a language which should be used by end web developers, it's not very popular, and that's for good reason. C++ has its own fair share of complexities. A C++ developer has to be very, very careful about how much memory they are using, and they need to be careful about managing the memory and all those things that are kind of given in Java and Python, right? Something that language takes care of you has to be done manually in C++. And for that reason, C++ is not very popular among web developers. That said, C++ can absolutely be used for web development. And you should actually prefer that in the scenarios where you need low-level programming. And when I say low-level programming, I mean if you need to be able to access very low-level details of your machine. For example, if you are creating a program which allows your user to control someone else's computer remotely, for example, a remote desktop program, right? You'd have seen that every once in a while where you can control someone else's computer from your computer over a chat, over Zoom, or over any other such social website, right? If you need that kind of control, right, C++ is most probably your best bet, because it will be extremely fast at doing the same things. Java, Python could also do that. They are general purpose after all. But C++ will be much, much faster and much, much more efficient at doing such a thing or achieving such a task than any other programming language. The last on list, but most important, because we are going to specifically target Node.js in our next webinar, is Node.js. Now, Node.js is very, very useful or very, very good at I/O intensive work. I/O stands for input output. When your web server is going to be doing lots of input and output operations, but not much of computationally intensive operations, not much of calculations, so to say. In that case, Node.js can be extremely efficient and very, very fast at serving your needs. Right? So if your web server design, if your program has to be I/O intensive, if it's going to be reading lots of files, it's going to be reading from connecting to databases and fetching lots of data from databases, or connecting to other computers, other servers, and then fetching data from multiple such servers, collating it, and then giving that out as output, right? In that case, Node.js is most probably your best bet. It will be most efficient among all these to be able to achieve such a task, right? Now, we are not actually going to see lots of programming in this particular webinar. We'll see various pieces that are required for building a backend server. In next webinar, we are going to build a web server from scratch. And there we are going to use Node.js as our primary programming language. Now, one of the main reasons Actually, I should go back to old slide for a second. One of the main reasons for using Node.js is because Node.js uses JavaScript for running code on server side. And as I said, right, choose the language you already know. And that is a great advantage in favor of Node.js. Any web developer will need to know JavaScript so that they can write code for browser. Browsers only run JavaScript. None of these languages are available in browser in a complete sense. Like they can be run in browser, but it has its own fair share of challenges. So JavaScript is the de facto standard language which will run inside browser. If if all web developers already know JavaScript, it makes sense to simply use the same language on server side also. Simply use the same language for building your backend program, right? That's the most important point in favor of using Node.js, and that's the reason we are going to see Node.js in action in our next webinar. Okay, let's move on to HTTP for a second. HTTP is the language which is used by various computers on web, various computers on internet in general, let's call it today, for communicating with each other. Even when you're trying to access a website like youtube.com, as you would have done right now, from your computer, you are actually not connecting to YouTube server directly. Instead, you are telling your browser that, hey, browser, go to youtube.com. And browser is the one actually talking to YouTube website, downloading information from YouTube, and then displaying it on your computer in a format that you'll understand, the audio visual information, right? Visual text, visual videos, and the audio that plays along with that, right? All that information that you can understand was fetched by your browser by communicating by establishing machine to machine communication between your computer and the YouTube server. For that specific part of communication, HTTP is the de facto language used on internet today. And I'm not saying this is the only language available. There are so many others. HTTP was specifically created for World Wide Web in 1989. There are others, but today, where we stand, HTTP is the most popular language and machine-to-machine communication language, and it has almost become the standard. Right. So I've given small example, like brief example of what HTTP request looks like, what HTTP response looks like. The one thing that I would like, the pieces of it I would like to highlight is this first verb over here. Let me see if I can draw on this. Yeah, I do have pen. Okay, so this piece that you see, this is called HTTP method. It's get over here. This basically represents what kind of action you want to perform with the web server, right? In this particular case, get represents we want to get something from the web server, right? Along with that, there is another piece over here. This is /index.htm. That represents what kind of resource or what resource you are trying to access on the web server. A single web server could provide so many different functionalities. For example, single YouTube server can host millions of videos, right? Most probably billions now of videos, and you are able to access each one of them uniquely by providing a different URL for those videos, right? So your URL is the identifier for the resource that you are trying to access. The source could be a video, it could be a blog, it could be some other text document, right? So till now we have seen the action that we are trying to perform, like HTTP specifying the action that we are trying to perform and the resource on which we are trying to perform that same action, right? Along with that, we have a bunch of, and by bunch of, I mean n number of, variable number of headers that we can provide. These headers provide extra information about the request. For example, in this case, one header is host, and the second header is accept, right? This is basically browser's way of telling our server that, okay, I was trying to access example.com website, and like I'm trying to access this resource on example.com website, and then with the accept header, it's trying to tell that I only understand text slash HTML. If you can, please provide me text slash HTML as output, because there are so many different kinds of outputs that a website could provide to the browser, right? It could be text in case of blog, it could be video. For example, YouTube provides video or audio, right? This is browser's way of telling that I only understand these particular formats. In case of YouTube, browser would most probably have told that I understand HTML as well as I understand videos and I understand audios and I understand images and so on and so forth, right? So this is the information that browser gives server to help server choose the appropriate output mechanism, right? So this is our request, and in response to that, a server will typically come back with something like this, where they give a status code, which you see as 200 over here, right? The status code basically tells success or failure information. It conveys the success or failure information. Was the server able to process the request successfully, or was it not able to? 200 means success. 300 will mean no, I'm not able to process your request right now, go somewhere else, right? 400 response will mean no, I was not able to process your request, there's something wrong with your data, you look for something like you look for a video that was not found. In that case, the response code would be 404. This is basically machines communicating to machines, right? So these numbers are basically for one machine telling other machine that what was the outcome of the request. Was the request successful? Was the request unsuccessful? Did did the server face some issue while processing request, and so on and so forth, right? For machines, this number alone is enough. But for humans, if some human was to look at this request, right, HTTP response also contains a textual representation of the same status code. If it's 200, then it will say okay. If it's 404, then it will say not found, and so on and so forth. Every HTTP status code will have a associated textual information, just in case some human is looking at that communication. If it's not just between machines to machines, right? If some human is involved, just to help the humans out, we include some English information about the response, right? After that, there are n number of headers again. Just the way we had headers on the request, we have headers on the response. These headers are sometimes standard. For example, content type, which is server's way of telling the browser that I'm giving you HTML content. Now, note that your browser could have asked for HTML already. But if the server did not understand HTML at all, right? If the server was incapable of providing HTML, server will still try to be nice and tell that, okay, I don't understand HTML, JSON is the only thing I understand, or image is the only thing I understand. So I'm gonna give you an image response. And in that case, server will basically need to tell the browser back that this is the type of content that I'm giving you, right? In this example that you see on your screen, server is telling that I'm giving you a HTML response, right? Along with that, server is also telling that the number of bytes that I'm going to transfer you is 155 bytes, and then some information about server and so on and so forth. After all these headers are done, right, there could be n number of headers, which server basically provides to the client to help them handle the response, right? After all these headers are done, right, server is going to send n number of bytes, and n basically is the content length that was already provided by the server. If server said that I'm going to provide 155 bytes as part of response, after all the headers are done, after you receive an empty line, you can expect 155 bytes to be sent back from the server. And this is how HTML communication typically goes. Because if you think about it, right, when machines communicate with each other, they cannot give contextual cues. For example, when you're talking to your friend, right, and you want to interrupt them, you want to tell them that, no, stop, and I want to tell something. You could, or you could basically raise your hand, or you could visually communicate to them that, no, 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 stop for a minute and let me speak. But machines cannot do that. For machines, it's all sequence of zeros and ones, right? It's all bits and bytes. For machines, there's no visual cues. And for that reason, the protocol must be very precisely specific. And that's what you see over here. The server is actually start from the client. The client is precisely telling what action they want to perform, what resource or what URL they want to perform that action on. I didn't talk about that, but there's also the HTTP version that they speak, and then what kind of request they can handle, some other information about the request itself or the browser itself. All that information is provided in very precise manner to the server, and then server is also equally meticulous. It it will be equally expressive in the response that it tells. It's not gonna let the browser infer from context how many bytes are going to come back. It's gonna tell exact number of bytes that the server is going to send back, and the browser is simply expected to read 155 bytes in this example and be done. Just after 155 bytes are read, client can be sure that there's nothing else that is going to come back from the server. Again, in a real world example, you'd have inferred that from some other mechanism, right? For example, if someone says bye or someone says no, I'm done, then you'll know that okay, no more communication is going to happen. You could hang up the call if you were on a call, right? But in case of machines, it has to be a lot more specific, and HTML provides that. Okay. I already talked about all this, so I'm gonna skip over this. This basically highlights what are different parts of the HTTP request. As we said, we have the request method, which was get in our example. There are so many other request methods like post, which is used to tell server that browser or client is trying to provide some information to the server, or put, which basically communicates to server that, which means to server that client is trying to replace some already existing content on the server. For example, if you already uploaded a video and you want to replace that video with something else, in that case, you use put method. Patch for changing part of information that already exists on server, and so on and so forth. There are so many other HTTP methods that exist. Request path is the URL that we talked about. Request headers is the mechanism for client to provide more information about the request itself or more information about the client, right? And request body is again n number of bytes that client wants to send to the server. Just the way server can send information back to client, client can also send information up to server, which that makes sense, right? If you're logging into Google, for example, at that point you'd want to send your username and password to the server so that they can verify whether it's correct and authenticate you, so to say, right? So yeah, just the same way that clients can send n number by specifying a content length header, server was able to send n number of bytes back to client. By specifying the same content length header over here, the browser could also send n number of bytes to the server itself, and server would have waited for those many bytes to read those many bytes before it goes on to the processing stage. Right. HTTP response we have already talked about. We'll quickly skip over that. Now, before we start with APIs, right, I'll take a couple of minute break and I'll wait for people to ask questions if there are any. I'll also drink some water. Okay. All right, seems like there are no questions, so I'll continue. But just in case there's something else, do interrupt me. On to APIs. APIs are just a specific use case for HTTP. Whatever you see over here, right, in our HTTP, the way we provide a method, the way we provide a path and headers and so on and so forth, all the information that we could potentially provide to server and all the information that could potentially be returned from server is infinite. And APIs, what they do is that they specify a protocol. They specify a set of rules that a particular application is going to use for communicating with its backend, right? For example, the URLs that will be valid in the front end, the URL that front end will be allowed to connect to in the back end, or the if front end is trying to connect to a particular URL, right, or a particular path, what information will be expected by the server, what headers will be expected by the server. um, is there some information that the client will need to provide in header? Is there some other information that client must provide in body, and so on and so forth? All these set of rules, which are not really generic enough to be part of HTTP, but will be required absolutely by the application. It will simply depend on your business logic. For example, if you were creating a shopping cart application, right? If you were creating an application which allows your users to browse different items on your site and then add some of those items to their cart and then check out by paying, right? In this case, for the, let's say, add to cart operation, it's imperative that the client provides the item that has to be added to cart, right? You cannot say add to cart and not provide the item. That does not make any sense. The user must be adding one particular item to the cart. Along with that, you must also provide a quantity. Whenever a user is adding a particular item to cart, they must say that I want to add one of this item, or you could be purchasing multiple items of one type, right? Let's say you are purchasing pizza on Domino's website. In that case, you'd want to say, I want to add one pizza of a particular type to my cart, or two pizza, or three pizza. So quantity is also a requirement when adding something to the cart. Now, this protocol, this set of rule that when add to cart API or when add to cart action is called, right? When add to cart action is invoked, at the very least, item name or item information and the quantity must be provided. This set of rule is basically in your application. This is not part of HTTP, but you must set this rule for your application to work correctly, right? And this set of rule, or this protocol is just a set of rules. I should clarify that. When I say protocol, all I mean is that we are talking about a set of rules that must be achieved for something to be valid. So API basically allows you to specify all these rules that are required for your application to function in some standard format, right? Now, what API does for you is it first specifies the structure of input and output, in what format the input will be provided, in what format the output will be provided. Clearing that out is useful both for the front end and back end. The front end can be sure that, okay, back end will always respond in this particular format. And same way, the server can be sure that whenever I receive a request to add item to a cart, I'll always receive the request in this particular format. Right? To get that out of the way is in everyone's best interest. An API would typically also specify the authentication requirement, whether a user should be logged in to add something to cart, or they could simply add to cart anytime, but they should be logged in to make a checkout or check out a cart, right? So all this information will also be part of your API specification, right? And third thing that API does is it makes your functionality shareable. What I mean by shareable is that once you develop an API, right, you could use it in your front end, or you could create an API which will be useful for multiple people. Take out the same checkout example that I talked about. There are so many websites in world. All of them have the exact same checkout functionality. All of them have the exact, like once you specify what items you are selling, right? The actions remain same on almost all of the websites. You browse the item, or your user will browse the item, and then they'll select a quantity and they'll click add to cart. After that, they'll have a checkout option. Once they click checkout, they'll make the payment and go about their rest of the day, right? Since so many people are using same functionality, it makes sense that some of the developers will at least think that, okay, let's add all these functionalities as API and then make it generic enough so that anyone can use it, right? And that happens. There are tools available like Shopify or even WordPress, which would allow you to create a shopping cart application at your whim, just like that. You won't need to write. You might not even need to write any code for creating that. But that does not mean that no one had to write a code. Someone did write that code so that you don't have to write the code, right? So APIs also make your functionality shareable. It allows you to write code once, which will be reused multiple times, either by your business itself or by multiple businesses across the world, right? Okay, the two boxes that I drew at the bottom, SOAP and REST. Now, SOAP and REST are two of the major techniques for creating APIs, or two major types of APIs that people typically create. I have striked out SOAP because SOAP is kind of outdated technologies. I'm not saying SOAP is not used anymore. SOAP is used, but no one writes a new SOAP API. It's outdated technologies, which is still in use simply because there are so many clients, so many people already using it, and no one wants to take on the challenge of overhauling the entire internet. That's simply not going to work. There are still browsers from 1996 in use today. So yeah, it's not possible to take anything off internet. Once it's on internet, it's on internet. So SOAP will be there for quite some time. But any new development, any new API development should not be done using SOAP. Instead, it should be done using REST, right? REST is a type of API which kind of takes a different. It adopts a very unique take on the entire World Wide Web. What it envisions is that the entire web is kind of representing a real world scenario, real world objects. If you think about it, right, and if you have some context in web development, sorry, not web development, programming in general, in that case, what I'm saying sounds very similar to object-oriented programming. When we talk about object-oriented programming, we say that it's a way of looking at programs in such a manner that every entity that we create in program mimics a real-world thing, right? REST does something similar. REST is the object-oriented equivalent of web development, right, or web APIs. What it says that everything on web is a resource, and all these resources have a unique address. All these resources can be reached by connecting to a particular unique endpoint, right? And conceptually, what REST allows you to do is that it allows you to fetch the current state of a resource. For example, when you try to view your cart, right, REST allows you to fetch the current state of your cart. If you have added 5 items in your cart, when you try to see your cart, what REST says is that you'll see the current state of your cart. If one more item was added, your current state, like the old view of your cart that you saw, is invalid. The entity cart, the kind of living, breathing thing called cart had changed. It has been mutated by your add to cart option since you added a second picture onto your cart, right? Now your cart contains 2 items, but the old view would still have returned 1 item. If you try to fetch the cart again, if you try to get the latest state of cart again, now you'll see 2 different items because that's what the cart is right now because of your second action, right? So REST protocol conceptually, and all this is conceptually because web development can be done without creating a REST API. But when you talk to REST, right, or when you read the documentation about REST, it will say that no, nothing on, like, everything on web is already following REST. Even if it does not strictly follow REST, it is already following bits and pieces that make up the REST protocol, right? So it allows you to fetch the current state of a resource. Along with that, it allows you to take various actions on the resource. One such action that I already talked about is adding to cart. And what you see on your screen is a reminder example, right? When you send a post request to /reminder endpoint, /reminder is the path of your reminder resource. Again, this is conceptual. there might not actually be a object-oriented thing called resource on the server. You might not even be using a object-oriented program on the server. But REST still envisions reminder to be a thing that exists, which is living and breathing somehow, and it can be mutated, it can change over time, right? So a post request sent to reminder resource allows you to create a new reminder, right? So when you send a post request to reminder endpoint and say that, okay, buy groceries is my input. In this case, a reminder will be created which will read buy groceries, right? And in REST world, what server will give you back is a identifier, is a unique ID, unique address to access your reminder resource that you have just created. Right. Now, in this particular case, I have quite naively said that the identifier for a reminder just created is 1. It could be a number, it could be a text, it could be any such thing that server wants to uniquely identify this reminder with. Right. Going forward, you will be able to interact with this reminder that you just created using this reminder ID 1. Right? You could either fetch the current state of reminder by firing a get request to /reminder/1 endpoint. Right? Reminder is your original resource, and then 1 is the ID assigned to the specific reminder that you just created. Right? So when you fire get request on /reminder/1, you get the current state of your resource. In this example, if you inserted the get endpoint call over here, you'd see buy groceries as the output. Right? The second option that REST provides you is to update a resource, right? You have already created a resource and you want to update it. For example, imagine you said buy groceries, but what you meant to say is that buy groceries tomorrow, or you made a spelling mistake and you want to correct that. In that case, what REST allows you to do is fire a put request. And all these post, put, and get, they mean special things in REST. They need not mean special things to your server, but if your server wants to follow the REST principles, right? It will always allow specific actions based on these HTTP methods. So put action will allow you to update an already created resource, right? Same way, delete action will allow you to delete an already created resource. If your reminder is no longer required for some reason, or you have already done what you wanted yourself to be reminded about, right? You can simply delete the resource by firing a HTTP request with method delete and path as your unique address of the reminder that you have created. Okay, that's pretty much our REST API. I've only talked about 4 things: get, post, put, and delete, right? But there are other actions that you could potentially perform. There's patch, which allows you to partially update resource, so partially update the reminder. Doesn't make sense in case of something as simple as this, but it would make sense if you were updating someone's user details, right? If you created a user and someone wanted to update their phone number, in that case, you'd not want to update the entire user. Instead, simply say that, tell the server that, okay, just update the phone number to something like this, right? That's the only piece that got updated. So you only want to talk about that. So patch can be used for that. There's options which could be used for getting details about the user, but some details about the user, but not full extent of the information, and so on and so forth. But most of the times, these are the 4 actions that you will be using, or rather, let's add patch to the mix. These are the 5 actions that you will be using: post, put, patch, delete, and get. Okay. Now, I have 2 more specific things to talk about. And since we have already crossed about 50 minutes, right? I'll quickly cover them. HTTPS is the technology created for achieving twofold objective, actually. There are 2 things that HTTPS lets you do. One, HTTPS allows your browser to identify and trust a server, right? And second, HTTPS allows all the communication between your browser and the server to be encrypted, right? Both of these things kind of get confused and tangled together, but they are very, very different. Identifying the server allows you to be sure that you are communicating with the right person. Encrypting the connection allows you to be sure that no one else will be able to intercept what you are saying, right? Mm, right out of the bat, those two are different things, right? When you call your friend, for example, you before you reveal some secret information that you have between you two, right? You'd want to identify that you are actually talking to your friend, and it's not the mischievous little sibling that picked up the call and is trying to get that information from you, right? So that is about the identification. The encryption, on the other hand, is about ensuring that no one else will understand what you're telling. For example, let's say you call, same example, let's continue the same example. You call your friend on their landline, and I'm not sure how many of you use landline today, but back when I was a kid and landlines were popular, back then you could potentially have more than one landline boxes connected to the same line. So it was possible that you're talking to someone on one box and someone else could lift up the receiver on the other box and hear exactly what you're saying, right? To prevent that from happening, you'd want to encrypt your connection. And one way to encrypt connection in real world would be talking code word, right? Assign words to mean something else than what they mean. Let's say you say, uh, let's meet at 5 p.m. and you have already communicated to your friend that let's meet at 5 p.m. means that everything is going well, or something like that, right? So yeah, these two are both very, very required and both kind of different things. And HTTP does two different things to establish both of them. Let's talk about identity first. The identity of server is established using a third-party intermediary called certificate authority. How this works is that, let's say you are meeting a new person, right? You typically not want to trust that new person immediately, right? And on internet, you are always meeting, like your computer is always meeting a new computer. There are billions of computers connected to internet at any time. And it becomes all the more necessary on establishing how your computer can trust a remote computer with, with the information and data that it's going to share, right? So what these certificate authorities do is that there are limited number of certificate authorities. Like, let's throw a number out. Let's say 100. There are 100 certificate authorities who have been trusted with this responsibility to certify some websites. For example, some certificate authority would have certified YouTube to be trusted, so to say. Right. Now, whenever you're and to certify them as trusted, this certificate authority, for example, let's take a random name, DigiCert. DigiCert is a certificate authority, quite prevalent in world. There's another one called Let's Encrypt. Whenever these companies certify a particular website as being trusted, right? They give them a certificate file. Let's just consider the file as a signature for the moment, right? Let's just assume that they literally pulled up a form, A4 sheet, and they signed on that, and they gave it to these websites that, okay, I trust you, and from my side, here's a certificate that you are completely trusted by me. Okay, DigiCert or Let's Encrypt just said that you're completely trusted by me. Now, all the browsers that we have, including whatever browser you are viewing this webinar in, already know about all these certificate authorities in world. Let we threw a number, said 100, right? There are 100 certificate authorities in world. Most probably there are more, but yeah, all the certificate authorities in that exist are already known by all the browsers. The list keeps getting updated from time to time. That's why your browser keeps forcing you to update the browser so that it has information on the latest certificate authorities, right? So along with the bug fixes, that's not the only reason for updating your browser, but Yeah, that's one of the reasons. So once we have all these, once a website has this certificate from CA, right? Every time your browser tries to connect to this website, the certificate will be presented by the website to your browser as a show of trust. Server will basically say that, hey, look at this certificate. I got this certificate from DigiCert. They said that I'm trusted. So maybe you should also trust me, kind of scenario. Now, if your browser recognizes the CA, your browser is basically going to say, yes, 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 I recognize the CA, I recognize the signature that is there on your certificate. And if DigiCert trusts you, that's good enough for me. I'm also going to trust you, right? That's typically how identity verification works for a particular server. Now, the same process can be done the other way around too. A server could also request your browser to identify itself. And if it was a highly secure environment, right, then a server would do that, ask you to present a certificate to identify yourself. But typically, that's not the case. Typically, server would just ask you to provide a username and password to identify yourself. But in some very, very secure environments, yes, the other side is also true. A server could request your browser to present a certificate um, obtained from some trusted authority to identify itself. Right. Do note that trusting a certificate only means that you trust the CA. It does not mean that the server is completely trustworthy, right? Most of the CAs would give a certificate to anyone as long as they are able to verify that you own a particular website, right? They'll give you a certificate um, for a price, of course. But you'll get a certificate for any website that you want to create. That does not mean that just having that certificate does not mean that the website owner cannot do something wrong with your information or cannot try to steal information from your computer. So you should not take HTTPS as meaning that server is not going to do anything bad. It only means that you know that you're communicating with youtube.com, you're communicating with google.com, and there's no one else in between trying to pose as youtube.com. No one else is saying that I'm youtube.com even when they're not. That much you can be sure. But apart from that, what youtube.com is going to do with your data is completely between you and YouTube. Now, like DigiCert makes, or HTTPS itself does not make any promises to that effect. The second part, of course, is encrypting the information that is that is transferred between your computer and the server. This is also done with help of the certificate. The certificate that I talked about, right, which has the CA signature, it also has something called a private key and a public key. I'm not sure how many of you are aware of specifics of cryptography, and I cannot get into details of that. That will take too much time, and most probably that's a webinar of its own. So we're not going to talk about asymmetric key cryptography. But you can think of private key and public key as very large prime numbers, and they can be used for anything encrypted using public key can only be decrypted using private key, and there's like anything encrypted in public key cannot be decrypted using any other mechanism except for having the private key. And since it's so difficult to generate these prime numbers randomly, right? With current computing power, it's almost 100% secure. If you encrypt something using a private public key, you can be sure that no one else will be able to decode it or decrypt it, right? So yeah, using the same certificate, you are able to verify that trusted CA issued the certificate, and since they also provided, they very conveniently provided the public key and private key also, right? So just using a public key, you could encrypt the information and be sure that only server will be able to decrypt it. Now, the specifics of this encryption is actually a bit more involved. We don't always use the public key for encryption because it's costly. It's computationally intensive to use this asymmetric cryptography. So we use something called symmetric cryptography, in which same key is used for encryption as well as decryption. What we do is that we create a random key, encrypt it using public key, pass out the encrypted information server, and at this point, server is the only one that will be able to decrypt it and get the random key that you have generated, right? After server does that, you know for sure that the random information, random key that you generated is only shared between you and the server and no one else in between, because it was transferred in encrypted format, and we already know that anything encrypted using the public key could not be decrypted without having the private key, right? So as long as the private key of server is safe with them, only you two know about this random key that was generated, and rest of the communication can be done using symmetric cryptography by encrypting the information with this random key. um, you could potentially just keep using the public key also. Like HTTPS does not force you to use this random key technique, but just to save computational power, right? Just to make it easier for a server to decrypt the information and easier for you to encrypt the information, even on a mobile device, even on a very low-end mobile device. HTTPS typically goes for symmetric key cryptography. Okay. Last topic for the day is, where do we deploy our backend? Like after we have created our backend, right? What do we do with it? Where do we finally put it so that anyone in world can access our website? Let's say you created a shopping cart web application, right? You'd want anyone in world to be able to access your shopping cart application so that they can buy stuff from you. If it's only running on your computer, most probably people won't be able to connect to your computer. But that's not absolutely true. You could deploy your website on your computer if you absolutely wanted to, but there are multiple challenges to doing that. And the least of the challenges is to keep your laptop running 24/7. You'd need to keep your server running 24/7, right? Otherwise, what if your laptop is in India, or you are in India, ergo your laptop is in India, and someone from UK or someone from US tries to buy something from your computer, right? If you simply close your laptop and go to sleep at night, no one in US will be able to use your website. And that sounds kind of unnecessary, right? If that's what you aim, that's okay. But still, it's most probably not the right experience to give your customer, even if your customer is in India and they want to access their cart information or their order information in middle of night for some reason they want to do that. Your website should be able to help them do that, help them achieve what they want to do, right? So yeah, deploying your server on laptop is possible, but most probably not a good idea. The second problem you'll face with your with deploying it on your laptop is that power backup issues. What if the current goes and your backup, your laptop battery dies, then also your server will go down. Or your internet issues. What if internet connectivity is lost in your home? Then also your users will not be able to access it. The laptop will also not be very secure, and so on and so forth. There are so many reasons that I could go on for hours about why you should not do that, why you should not deploy your server on your laptop. For development, that's fine, but for final deployment, that's not. So what do we do? Where do we finally put our server? And the answer is typically the cloud. You put your server, you deploy your server on one of the computers that are already created for this particular purpose. One of the computers that are created and maintained by someone else, so that its security, its internet backup, its power backup, and all those things simply stop being your headache. Someone else takes care of that, right? So you find a provider, someone who is willing to rent their computer to you, and beyond that, you simply deploy your code on their computer and let it run, right? We move on to our next slide, right? Cloud is basically a collective term used for servers and all the software that is running on server, which is provisioned, maintained, and accessed over internet. By provisioned, I mean which is rented over internet. It is maintained over internet, as in you will be able to add your code to the server. You will be able to make some changes if you must, right? You'll be able to make some changes on your server. For example, adding a HTTPS certificate, or um, updating your information, updating contact information on your website, or just deploying a completely new version of your website, right? All that should be doable over internet. Since you are renting this server from someone else, you can be sure that you cannot just go to that computer and manually type on its keyboard. That's never gonna work out, right? Because the server could be in Mumbai, or it could be in Los Angeles or San Francisco. You never know, right? So the servers should be provisionable and maintainable over internet, right? All these things, all these features are typically provided by your cloud providers. I have highlighted 3 of them over here, and I only put 3 over here because of constraints, because of the amount of space I wanted to, or I had. But there are so many more. AWS, GCP, which is called Google Cloud Platform, and Azure are 3 major services by Amazon, Google, and Microsoft respectively. But there are so many other such cloud providers which give you almost same functionality, most probably using services of one of these 3 providers, but adding on to that, providing more than like extra functionality that could be useful to a web developer on top of all this, right? So yeah, when you do go with one of these cloud providers, right, when you rent a server from one of these cloud providers, you can be sure that the installation and maintenance will be taken care of by someone else. You can be sure that when you rent a server from AWS or GCP, Amazon or Google respectively, will install your server and they will maintain your server. They'll ensure that all the latest security updates and all the latest updates that are required on your server are always there, right? And that can be a huge benefit for you. It will give you the peace of mind that apart from the changes that you make, you don't need to worry about anything else. You can be sure that your server will keep running forever if you don't need any other change, right? They would also take care of server security and connectivity for you, and they would also defend you against any kind of malicious attacks. If you're creating your own server, you'd need to do that on your own. Like you'd need to install your own firewalls. You'd need to ensure that no bad actors are able to access your server on internet, and that can be tough. And it's a bit of a cat and mouse game. You don't know about all the attacks that are there. You only know about some, and you'll prevent your servers, or you'll safeguard your servers from those attacks. But all the time, new and new, like the spammers and the attackers, they are also innovating. They are also trying to figure out new ways of attacking different servers. So you kind of need to keep your security mechanisms up to date. Using a cloud provider gives that to you out of the box. And I say out of the box instead of for free, because cloud is not free. It's typically paid. Except like for trying it out, it might be free, but in most of scenarios, cloud servers will be paid. I personally believe it's totally worth it, given all the benefits that they bring, right? It's completely worth it. So what are different types of cloud services that you could rent, right? There are 3 that I mentioned over here. We'll very quickly scan through those. IaaS is infrastructure as service. This is the scenario in which you are renting bare infrastructure from the cloud provider. This would be equivalent of buying a normal computer, buying a regular computer from store to run it as a server, buying a new laptop to run it as a server, right? Just that buying a new laptop is going to be very costly for you. Renting infrastructure can be extremely cheap in short term. In long term, if you want to run it for hundreds of years, for example, right, then most probably buying that server would have been cheaper. So you need to kind of balance that out. Okay. Another example that I typically take when comparing these 3, right, IaaS, PaaS, and SaaS, is of pizza. Imagine that you want to eat pizza, right? You need pizza basically. IAS would basically mean trying to build your own pizza, trying to build your own shop for making these pizzas. It's you need the dough, obviously you need the toppings, you need the sauce, but along with that, like all that you would have needed anyway, right? That's minimum requirement for pizza. But along with that, you'd also need an oven, which can be very, very costly one-time investment. No, if you're going to be making pizza all your life and you're going to sell pizza, right? Then it makes sense to invest in that oven. But for if you're just hungry and you want to eat pizza, it makes no sense to invest in that oven, right? It can be very prohibitive and very costly to set up that one-time infrastructure, right? And for that reason, you'd want to buy infrastructure as service to avoid buying the infrastructure, but still have all the control that you'd have had if you bought your own computers, created your own servers, right? PaaS, that is platform as a service, is built on top of IaaS. It's basically one layer on top of infrastructure as service. In this case, you don't need to worry about buying the server, buying the infrastructure. Along with that, you don't even need to worry about how your code is run. You just need to provide your code, provide your backend server, and then the PaaS provider is going to take care of executing it for you. They'll also take care of things like ensuring that there is a HTTPS certificate, ensuring that your HTTPS certificate is always valid, ensuring that your server is always running, like even if your code had some issues and it goes down, right? Ensuring that it's restarted immediately and so on and so forth. All those services will be provided to you for free in PaaS. In the pizza example, you could think of PaaS as Domino's. When you want to buy a pizza, Domino's still gives you kind of lots of options. You could still have thin crust or medium crust or cheese-filled crust or so many different kinds of crust, right? Along with that, you could have multiple different cheese, multiple different toppings, and so on and so forth. But it also abstracts away some other things from you. For example, any crust that is not available on Domino's, you'll simply not be able to use, or any type of cheese not available on Domino's, you'll not be able to use. Right? IAS, you'd have had all those, all that power basically of doing whatever you wanted, buying a new type of, making a new type of cheese altogether, making a new type of dough altogether. PaaS, you'll have to go with what the provider already had, but it can reduce a lot of headache for you, right? It can make your job much easier, right? Moving on to SaaS, it's software as service. It is basically pre-built, pre-deployed software. You don't even need to write code to use that, already running on some server. All you need to do is simply start using the services provided by SaaS. In the pizza equivalent, it will be equivalent of stealing your roommate's pizza. For example, imagine your roommate added, your roommate ordered some pizza, right? And they just kept it on the kitchen counter and they forgot about it, and you take it and eat it out. In this case, you have no flexibility whatsoever. You have to go with whatever pizza your roommate added, right? It need not be stealing, it could be sharing, right? So the point is, you have no flexibility. You have to go on with what you are given, but it can still be very useful. SaaS can still be very useful for things like database. For example, you don't want to purchase a completely new database software and the server to run that database software on your own, and all that same problem. All that will be very prohibitive on the cost front. In that case, you could use a database which is provided as a service, right? And to that note, you'll see things like BAS and DBS. And so DBS is actually very unfortunately named acronym. But yeah, what I want to say is that database is being provided as a service, which is same thing. That DBS is, or DBAS, let's call it, is a type of SaaS. It's a database being provided as a service, right? So it's a type of software as a service. And BaaS, again, backend as a service, is a type of PaaS. It's a platform being provided as service. And I didn't even have mentioned these two because they are SaaS and PaaS respectively. But the reason I did is because you'll see lots of these acronyms where they'll put one or two characters and then AAS, which basically stands for as a service. You'd see something like DaaS, desktop as a service, in which the cloud provider basically allows you to create a desktop in the cloud and be able to use that just the way you'd have bought a new laptop or desktop and use that, right? And there are so many other things that could be provided as a service, like GPUs are these days provided as a service for doing really parallel computationally intensive tasks, right? Okay, so with that, I will pretty much leave it here. In the next webinar, we are going to see how all these different technologies that we have talked about come together to form a particular web server for you. We'll use Node.js for building out our web server, and we'll also try to add HTTPS functionality to our web server and deploy it on IaaS. I'll go for IaaS so that of all the steps that are involved in creating a web server. PaaS kind of abstracts some of this out for you. If you wish to use PaaS, right, for deploying a server, all you need to do is skip a couple of steps. Like some things that you would have had to do on IaaS yourself will be done automatically on PaaS. That's about it. Apart from that, um, it's the process is pretty much exactly same, right? So that's for the next webinar. For this webinar, that's it from me. I'll stop and open up for questions and answers if there are any. Okay, I don't see any questions right now. So on this last slide, I have shared my LinkedIn address. If there are any questions, we'll wait for a few more minutes. But if there are any questions later, right, you can always reach out to me on LinkedIn. Okay, so I'm being asked to run through the slides one more time. I will very quickly do that. Let's go to the first slide. Okay, so I'm basically just running through the slide very quickly, just in case you need a quick reference, right? You could just come to this part of video and look over the slides. All right then. That's about it from me. Please do reach out with any questions that you have. Even if you are watching this video later on YouTube, right? You can always ping me on LinkedIn and time. Thank you, everyone. And I'll see you guys for the Node.js sessions shortly.